Hello. The goal of this video is to introduce you to some operations on sets. By the end, you should understand the definitions of a Cartesian product, subset, union, intersection, difference, and complement. You should be able to decipher and produce examples of these definitions using finite sets and our very important examples. Okay, so let's suppose that A and B are two sets. And the first definition that I'm going to give is the definition of the Cartesian product. So we say that the Cartesian product of the sets A and B is, and I'm going to write this in set builder notation. So it's A cross B, and it's the set of all ordered pairs where the first element has to be from set A and the second element has to be set B. So it's the set of ordered pairs A comma B, where A is in A and little b is in B. So for example, if A is equal to the set 1 comma 2 and B is equal to the set A, B, C, when I form the Cartesian product, A cross B, I'm going to have two options for the first component. They can be a 1 or a 2, and three options for the second component. Those can be A, B, or C. So altogether, I'm going to get 6 ordered pairs, and they're going to be 1A, 1B, 1C, 2A, 2B, 2C. Okay. And of course, to really understand the definition, you'll have to do lots of different kinds of examples to see how different things work out. Something I want to point out now is that these pairs are ordered. So B cross A is going to be different than A cross B. If I looked at B cross A, I'd have 3 options for the first component, A, B, or C, and 2 options for the second component, just 1 or 2. Okay, so you try to write it out. All right, the next operation that I want to tell you about is the definition of a subset. So we say that a set X is a subset of a set A if every element of X is also an element A. So for example, let's suppose our set A is the set 1, 2, 3 this time. If I want to think about what set might be a subset of A, so let's say X, the set containing 1 and 2. So I've taken some of the elements of A, but not all of them. This is a subset of A, and that's how we write subset, with that sort of on its side U. And when we have this this line under it, we're saying it might be equal to A. I'm allowing it to be equal to A. It's not here, but I'm not emphasizing that. Okay. Sometimes in a picture might help. I can think of my big set A as being a big blob and a subset X X is a subset of A if it's contained in the bigger blob. Okay, so that's what the picture might look like. The next definition that we'll need is union. So the union of A and B consists of all elements in A or B, and in set builder notation, so if we use this U for A union B, and in set builder notation, we write it's the set of all X such that X is in A or X is in B. So for example here, oh, and maybe I'll draw a diagram. If your set A is represented by that blob, and your set B is represented by this blob, then the union consists of all the things that are in A or in B. Okay, so for example, if A is the set 1, 2, 3, and B is the set 2, 3, 4, then when I look at their union, so I get the things that are in A or B. So I'll get 1, 2, 3, and 4. Okay, because each of those elements is either in A or in B, or they could be in both. That's okay too. And note that the elements that are in both of them, I don't list them twice. I just list them once. Okay, so that's the union of those two sets. If I took the union, for example, of A with a set like 1, 2, that's a subset of it, I just get the original set A back again. Okay. And we'll look at lots of examples of this when we talk about it in class. Then there's the intersection. The intersection of A and B is denoted A, and here we turn that union sign upside down, A cap B, and it's the set of all X such that X has to be in A and B. It has to be in both of them. So X is in A and X is also in B. So in terms of diagrams, again, if A is this blob and B is this blob, the intersection consists of the elements that are in both of them. So they're the overlap. Okay. So if we're using our same set A and B from here, so A is 1, 2, and B is 2, 3, 4. Then if I look at A intersect B, the elements that are in both of the sets, it's just the elements 2 and 3. Okay. So we have two more definitions. One is set difference. The difference A minus B in set builder notation, it's the elements that are in A such that they are not in B. So it's the elements of A take away the elements of B. The picture that goes with that, there's A, here's B. I keep the elements of A that are not in B. So in particular, I'm taking away the intersection of the two of them. Okay. So again, going back to our example where A is 1, 2, 3 and B is 2, 3, 4, if I do A minus B, so I'm going to take away I'm going to start with the set A, I'm going to take away from it the elements that are also in B. So if I have A minus B, since my set A is 1, 2, 3, and I'm taking away the set elements in 2, 3, 4, what I'm going to be left with, the ones they have in common are the elements 2 and 3. So I need to take those away. I'm just going to be left with the element 1. Okay, so in that blob diagram form or Venn diagram form, here's A. It's the set 1, 2, 3. Here's B, which is the set 2, 3, 4. And what I'm left with when I do the A minus B, I'm just left with the set containing 1. Okay. And then finally, I wanted to find for you what the complement of a set is. And so we need another notion first. Let A be a set contained in some universal set, in a universal set, U. So definition, the complement of A is, I'm going to denote A with a bar on top. And in set builder notation, it's the elements that are in our universe such that they are not in the set A. Okay, so here, the way I would draw this, I think of my universe of all possible elements as being U, this big box, and inside U, I have my set A, and the complement of A in U is all the stuff outside of A, the elements of U that are not in A. So for example, if I had my universal set as the set 1, 2, 3, 4, 5, and my set A is the same set we've been using, 1, 2, 3, then the complement of A are the elements of my universe that are not in A, and that's just the elements 4,